Hello again, it's Christian Seaman with Peregrina Solutions LLC. Today I'm going to be showing you some basics on how to set up your 3D printer. This is a non-self-leveling one, such as an Ender 3, a Creality Ender 3 model. I'm going to go through some tips and techniques that worked well for me. There are a lot of other videos on the internet that I watched when I was getting started on 3D printing that have some great details. This is going to be kind of a summarization of what really worked for me to get the bed nice and level. For me and most people, this is the most critical step you'll find once you get a little more familiar with 3D printing, to making sure that your 3D print files go from the computer into a nice actual 3D object that you like, rather than a pile of plastic spaghetti that just makes a mess and frustrates you. So with that being said, let's get started. Alright, so through the magic of a lot of zeros and ones, we find ourselves in front of a Creality Ender 3 printer. Now this is the bed here. It slides forwards and backwards, and then this is where the extruder is, below here, the hot end, excuse me, and basically the extruder is right here. The filament feeds in this way, loops up and around, and then goes down through the hot end where it's heated up, and then it's extruded out through the bottom here. I will show a close-up of that. Alright, so you can kind of see some 3D filament that's hardened. It's coming out of the bottom. 3D printing, the most important thing is you want this surface here to be nice and flat, and you want all the corners to be at a uniform height, so that the center area that you're 3D printing, and you're basically what that means is you're extruding the 3D printed media material filament. You're heating it up and then extruding it out in a liquid, liquid form, like a soft serve ice cream, and you're building it up on the surface layer by layer by layer. And that layer height is a function of what you determine in the 3D printing software. I like to use Ultimaker Cura. I'll put a link to that in the description. There are a bunch of different softwares you can use, but that's a very popular one. It has a lot of tutorials on it, so that's the one I ended up using. Now, in order to get this level, there are these, in the Creality Ender 3, there are these little set screws. If you go in this direction, which is as you're looking from the top, if you're going in a clockwise direction, it raises the build head and makes it like a tighter fit between the extruder and the build plate. Whereas if you take the knobs here, there's one on this side, one on this side, and then in the very back there's another one here, and then there's another one over on the back corresponding here. So as you're looking from the top, if you do counterclockwise, it tightens this spring that's on the bottom side here, making the build plate go down, increasing the space between the hot metal end here, the little tip, and the build plate. And then if you rotate this clockwise, it loosens the spring underneath here, allowing the build plate to go up, decreasing the space between the build plate and the tip here. You want it to be basically pretty much the exact thickness of a standard piece of paper. And what I find is, and I'll show this once we get the video started, or once I get the machine started here, is I will set the machine to auto home. Prior to doing that, I like to take this tool, this little very sharp clipper tool that comes with the machine, and remove any filament that is coming out of the extruder head. So you can see, just on the piece of paper here, and on the build plate, kind of see that little piece of filament here. So we just get rid of that, and then we just take our paper here. We'll set the machine to auto home. It'll basically bring it over to this, and it'll bring this back like this. It checks it and brings it to the exact height that it's going to be at for the first layer. And then you disable the stepper motors. There's a stepper motor that controls the height, this build plate going back this way, and then this motor going back and forth this way. And you want those to be off so you can adjust the build plate back and forth to check the height on this corner, this corner, this corner, and this corner. And after you do that a couple of times, if I like to do it once each corner as I make adjustments, and if I make an adjustment, I'll go back and do that all again. And I'll keep doing that until I've gone around the entire thing and don't really need to make any adjustments anymore. You basically want this so as you're lightly pulling it with your fingers, just like this, you could just barely feel a tiny amount of friction between the build plate and this head that's on the bottom here. And again, the reason you want to clip any filament sticking out of the bottom here is if you have filament sticking out, it's going to give you an inaccurate feeling or measurement on the thickness here, because it's going to be decreasing the thickness by whatever amount of filament sticking out. If you have that, you're going to have too thick of a distance between the build plate and the extruder here, and you're not going to get a nice smush of that filament. It's probably going to just not even adhere at all and pop off, and the next thing you know, you'll just have a giant mass of spaghetti or tangle of filament on your build plate here, and it's just a mess. I usually recommend that people stay around their 3D printer just to make sure if you have any problems, you can stop it immediately or pause the print and address those issues immediately, rather than wasting a bunch of time and filament because you just had it printing while you weren't around. In the past, there were some experiences with people having cheap power supplies on these that were it wasn't the people that bought them put them on. They were just supplied with whatever manufacturer made the printer with this issue with the power supplies. They were catching on fire. So you also kind of want to be around any sort of electronics that are operating like this. They're not ever supposed to catch on fire, but if you're around and they do catch on fire, you can extinguish the problem before it becomes a real issue. Okay, so turning on the Ender 3. There's a little switch over on the side here. It's a little red switch. Once you turn that on, the screen will power up. There's a little wheel here. You press it in, and you can turn it to scroll. You go to Prepare, scroll down to Auto Home. As I said, that moves that back over in that direction, and it starts lowering this whole carriage down to the level of the build plate. There's a little switch here when it reaches the bottom. It hits that, resets, it goes up, then it hits it again, comes down. There's one over here to make sure that this is all the way to the side as well. So, now that that is there, we will come back to this screen, go back to prepare, and we'll scroll down. I don't know why this is so blurry, but it is. You hit disable steppers, that turns this off, and now we can move this. If you were to try to move this before doing the stable stepper section, you wouldn't be able to move these without pushing them so hard you'd break something, or potentially break something. So you bring this over. I have, as you can kind of see from the discoloration ring, that is some built up hairspray. So that kind of brings this layer height up and causes a similar issue as to having the filament sticking down, only it's a much thinner layer here. So what I like to do to avoid any inconsistencies from that is I bring the extruder head over to the edge. It's basically right below this. So I bring it over to the edge so it's not on this ring. I'll check it here, 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 and then here, where I'm not going to run into any issues from the build plate height being misrepresented by the hairspray. So I can feel already that the hairspray there was kind of making a little bit of an issue. When you have this hot, when this is all hot, the build plate is heated up, and this extruder is extremely hot. It's 200. You can have it whatever the 3D printing filament you are using suggests, but typically for PLA it's between 200 degrees Celsius and 215 degrees is a common extruder temperature, or hot metal end temperature. So as I can see, this, you can kind of hear a little bit of friction there. I can, just from experience, I feel like I could just do like a tiny little adjustment on that, but really probably didn't need to. Now that I'm over here, kind of the same thing. It's ever so slightly. I'm just gonna, maybe I'm rotating my finger, as you can see, move the thing, maybe about that much. So a degree, maybe like 2 to 3 degrees of a turn. And you can see it definitely adds a little, basically if you can touch the paper and it's that much of a difference and it kind of almost bends, that's like the perfect amount I've found. So basically we didn't really adjust there much. This is pretty much the same deal as the front, but so I'm just gonna do it like a degree or two, and that feels nice to me now. This one is a little bit firmer. See, if you go like this, the paper just wants to bend. So we're going to go bring it this way, counterclockwise from looking at it on top. Spin it. I'm going to do like 2 to 3 degrees there. It's a little bit firmer still. Try another degree. Okay, so that's nice, right like this. Come around to the front. Same deal, nice, same as before. Same here. You can see the difference between this outer band of the hairspray as you go along. It really makes the friction increase. But as I was saying, when this is all hot and the extruder's hot, it just melts right through that. Doesn't create an issue. So we did that one. We're just going back around to double check everything. This one's still nice. This one's still nice. And this one's still nice. I like to go around and just do this every single time I print, because this maybe took us 5 minutes to do. If you're going nice and smooth, it takes maybe just a minute or two tops, and it sets a precedent for your prints going nice and smoothly each time. So I like to, rather than you maybe doing this half-heartedly or not at all, kind of thinking like, oh, I got it fine the last time, nothing should be wrong. Well, usually it's off ever so slightly if you don't do anything. Sometimes it's like this. A lot of times once you get it really set up nicely, if you pull these clips off, then are careful when you remove the glass build plate here, which I will show you in a second. If you take these clips off in the front and back, and this, all it is just a piece of glass from your local hardware store, and you can just go into any of these places, give them the measurements of your build plate, and they will cut you a nice piece of glass. And this is, in my opinion, the best material for printing on. Glass is not, very few materials are perfectly flat. Nothing's really perfectly flat, but glass is a fairly flat material because they pour, glass is a liquid. It's the most viscous liquid, or one of the most viscous liquids out there, but it's always in a slight state of flow, which is why on old glass buildings and stuff with old windows, you can actually see it almost kind of dripping down. It's pretty cool. Anyways, when they make glass, they pour it onto a very flat surface, and it will just come out, and then they can it's smooth. It's almost self-leveling at that point, so it smooths out, gives a nice surface on the top, and then they can cut it into nice flat sections, giving what we have here. And when you're printing with this stuff, I prefer to use a hairspray to make a nice microscopic thin film layer between the glass and whatever filament type you're printing with. If you're printing with certain filaments like PETG, they will actually fuse to the glass plate here so strongly that you can end up chipping out pieces of the glass, and no one wants that. It's bad for your 3D print, and also you ruin your piece of glass. You can avoid all of that just simply by spraying on some nice cheap hairspray like this Rave or Aquanet. I just give it so basically we've already leveled this out. Before I start heating up this build plate, we're going to just give it a quick coating of the hairspray like so. You can smell that. We're going to turn what I have here behind the thing is a HEPA air filter. I like to turn that on. And then, so just manually moving this back here, go over to the on screen here, you go back to prepare. This is, so yes, got a little ahead of myself. So you go back to prepare, keep scrolling down. This is on the Ender 3. It's going to be a little different depending on what kind of printer software you have. You go to preheat, and then you have these options here. You can just preheat PLA the end and the bed by doing this preheat PLA, or you can specify whether you want to do the hot metal head end only, which is that part that the filament comes out of, or you can also choose, I'm going to go back to there because it timed us out of that. You can also choose to preheat just the bed itself. That's the print surface only. So we're going to be 3D printing, so we want to heat up the extruder and the hot end along with the build plate. So what this reading here is doing is it's going to heat up to 220 for the extruder. It's going to heat up to 50 degrees for the bed, and then the lower temperature is the temperature it's at this current point. So it's 74 degrees for the extruder, 26 degrees for the hot end, or excuse me, for the bed, and they both heat up pretty quickly. This is the fan speed. There are two fans on the hot end that help cool the build surface, or the extruder area, and then just help provide cooling into the fan shroud itself. So now that we've done that, if you have, there's a slot right here for your micro SD card to go. We're going to assume that you already have the STL file. I'll make another video on this, how to use the Ultimaker Cura software to print this stuff, or how to get it from the internet and then onto the Ultimaker Cura, put it onto a micro SD card like this. So we're assuming you already did that. It's in here. We're heating up. We're doing the preheat PLA setting. So this is already pretty warm. And then you go down to print from key F. And these are some of the ones I have. Right now, the last one I did was this 115% Montana mask. That's the mask itself, and that's the name that they gave it, the original creators. So I was doing that. You would select this, and it would basically, provided that everything's up to temperature, it would immediately start printing. And yeah, that would be it. You just keep monitoring it from there, and yeah, just wait for it to print out.